Um, so specifically, I wanted to start with a problem like this because I wanted to understand that absolute value symbol is not a grouping symbol. And you can say, what are you talking about? Well, you are not allowed to distribute 3 inside. Do not treat the absolute value as if there were parentheses and now I'm going to factor out and I'm going to distribute. No, that's not allowed. But what is allowed and we have to do is, remember what I like to say, sometimes clean it up. Either factor or simplify. Is there anything I can do to simplify this? The answer is yes. I will divide both sides by 3. 2x minus 1 in absolute value equals 7. Now finally we are back to this simple example. I have whatever in absolute value equals 7. What can this whatever be? Let's say 10. No, the absolute value of 10 is not 7. Let's say negative 3. No, the absolute value of negative 3 is not 7. But what can it be? It can only be or exactly. So there are only 2 possibilities, that 2x minus 1, the inside, equals 7, or 2x minus 1 equals negative 7. Yes, you're going to say, I haven't finished, I haven't solved it yet, but I will. So I have to solve 2 linear equations now. I'm going to add 1 and divide by 2. I'm going to add 1 and divide by 2. So what is the first solution then? 2x equals 8. X equals? Perfect. 2x equals negative 6. So x equals? That's it. And these are the solutions of the absolute value equation. I think it's about time for us to work on a problem on our own. And then we move on. Let's say 72. 4. Absolute value 1 minus 3/4 x plus 7 equals 10. Remember to clean it up. Remember to raise your hand. I'll come and help you. Anyone needs help? Can anyone tell us at least which step would you perform first? Say it again. 7, yes. Subtract 7 from both sides. Awesome, thank you. Yes, indeed, that would be the first step. Can anyone give us a second step? Of course. Remember, you cannot do anything inside the absolute value. And now you'll have two options. And let me know when you find those two options. So 1 minus 3/4 x equals, yes. And the second option is? Very good. That's it. Absolutely. Is it done? No. Now let's talk about these two equations and see how we address this. Here is the option I recommend. Multiply both sides by, indeed. Eliminate fractions. You don't have to worry about fractions. You don't have to be afraid of fractions. You just get rid of them. So this is 4 minus 3x equals 3. When you multiply the first term, you get 4. When you multiply 3 over 4 by 4, you only get 3. When you multiply 3 over 4 by 4, you only get 3, because 3 over 4 times 4 over 1 don't multiply. Simplify first, and you get 3. That's the idea, not to multiply, because you want to simplify. You want to get rid of the fraction. And this is now no problem. I'll move forward to the other side, subtract 4. So I get negative 3x equals negative 1. Stop me if you have questions, please. So negative 3x equals negative 1, because I'm moving forward to the other side. And then x equals 1/3. And that would be the first solution. Do we have the second solution? So you have 4 minus 3x minus negative 3, yes. Negative 7, so x equals 7/3. Because I multiplied by 4 again. So I get negative 3x and then negative 3. And then I subtract 4, I get negative 7. Negative 7 over negative 3 is 7/3. Is that okay? We keep talking about radicals, and I just want to give show a word problem about radicals. Any questions before we continue? So we can finish up section 1.6 and start inequalities. But I'd like to work on a word problem. Is that okay? Yes? Okay, so let's look at 110 on page 187. Because all this theory is nice and interesting, maybe, for everyone, but where it's applicable, it's more interesting. So we're given a formula, P equals negative 1.6 the square root of T plus 62. Models the percentage of jobs. Every time I read, I take notes. Percent of jobs in the U.S. labor force, P, held by men, T years after 1970. T years after 1970. What does T represent for 1970 then? 1970 has T equals for somebody born in 1970, how old is that person in 1970? Exactly. So then 1971 will be 1 year since 1970, 1972 will be 2 years since 1970, and so on and so forth. So these are the notes from the first sentence. Use the appropriate graph at the bottom of the previous column to estimate the percentage of jobs in the U.S. labor force held by men in 2010. So I'll show you Give your estimate to the nearest percent. So now I'll show you the graph. Let's look at the graphs. So here are the graphs, as you see in blue and in red. So it says use the appropriate graph, the appropriate one, the one for men. See the labor force held by men in 2010. I see 2010. I go to the blue dot and I try to estimate 50%, roughly. Okay? You may say maybe a little bit more than 50%, right? Maybe, I don't know, 52, 53. Okay, perfect. Part B, use the mathematical model that was given to us to determine the percentage of jobs held by men in 2010. So first we read from the graph. Okay, so we're going to write it down. Part A. In part A, we read that for 2010, P was, we decided to put 53%. In part B, they're asking us to use this model and determine the percentage for 2010. So how do I determine that? How much is T for 2010? Knowing that 0 represents 1970. So that would be 40 years. What do I do with 40 years? Plug it in. So then P will be negative 1.6, the square root of 40 plus 62. Let's do that together. Here it is. Negative. When you start with a negative, please start with this symbol. Negative 1.6, the square root of 40. You know me already. Go outside, plus 62. This is overdoing it. I just want to see parentheses, though, in there. And then I press enter. And the model gives us roughly 52%. In part C, according to the formula, when will 49% of jobs in the U.S. labor force be held by men? When 49% will be held by men. So what do I do now? Thank you very much. Now I have to ask myself, what type of equation is it? Because I know many. I know linear, I know quadratic, I know radical, I know rational. I know quadratic in form, I know absolute value, and I know those with rational exponents, fractional exponents. Which one is it? And what do I do first? I have to subtract 62. So 62 minus 49 is, I think, 13. So this is negative 13, negative 1.6, the square root of 40. By negative 1.6. So I have 13 over 1.6. I'm sorry. Of course it's T. Now, sorry. I'm not tired. I don't know. I just didn't copy the right one. Not the 40, of course. It's negative 1.6, the square root of T plus 62. Okay, very good. We move 62 to the other side. We divide by 1.6, and then I realized that, good. So you still haven't told me what perfect steps, excellent, but what type of equation is it? What type? It doesn't have a fraction with x or t in the denominator. It doesn't, linear equations don't have the square root on top of the variable. What can it be? Of course. It's a square root equation. I just said that, right? It would not have a square root on top of the variable. Of course, it's a square root. It's a radical equation. Good. So now I know what to do. What am I going to do? Of course. So then t equals, and I square, I get, so I square s in parentheses 13 divided by 1.6. Close the parenthesis, and then square. 66.01. What does 66.01 or just 66 mean? Since or after 1970. After 1970. So t will equal, so 1970 plus 66, it's 2036. So women will overtake men in about 16 years, if the model is still correct. You guys are going to be 49% of the workforce, and we, the ladies, are going to be 51%. Occupy 51% of the workforce, if the model is still true. Good. Inequalities. I know I have 5 minutes left. I just want to refresh your memory on something very simple, and then we'll continue on Wednesday. So 1.7 inequalities. Okay, why do we need inequalities? Equations are not good enough? No, they're not good enough, because when we want to compare, we're not setting equal two sides, where we just want to compare them, which one is larger. So that's when inequalities come into play. And I just want to refresh our memory on linear inequalities. Just one problem and we'll stop. Let's say 42 on page 203. 3x divided by 10 plus 1 greater than or equal to 1/5 minus x over 10. This type of problem could have not been solved using an equation, because we're comparing two sides. We're not setting them equal to each other. We don't want to determine when they are equal. We want to determine when one is bigger than the other, or even equal to. Of course, we're going to get rid of we are going to get rid of all fractions at once, as we did before, multiplying both sides by, indeed, by the least common denominator. So please remember, we multiply everything. So just write it like this, as 10 over 1, this one times 10, this one times 10 over 1, and this sometimes 10 over 1, because I want you to simplify first, not multiply. We don't want to multiply, we want to simplify. So I'll simplify these two, I get 3x. I'll multiply these two, I get positive 10. I simplify these two, I get 2. And I simplify these two, and I get x. This is way more human than the original one. You don't want to mess with those fractions. It's not a friendly, user-friendly type of problem. Eliminate all fractions first to make your life easier. And now this is a piece of cake, right? So I move x and I move 10. So when I move x, I get 4x. When I move 10, I get negative 8, because it's 2 minus 10. And then I have x greater to negative 2. Now, final step here is to use the interval notation. So look at the real line. This is 0. This is -2. I don't care for units. So this is what we are interested in. That's what it says. -2 or above. And this is the interval notation. Any questions?